Coming up on Destination Tomorrow, we'll travel to NASA Johnson Space Center to find out why radiation will be one of our major challenges as we prepare for missions to the Moon and to Mars. We'll also travel to Brookhaven National Laboratory to examine how researchers are studying the effects of radiation on human tissue. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to this edition of Destination Tomorrow.
On this episode, we'll be focusing on how radiation will affect our efforts to reach destinations like the Moon and Mars.
In recent years, NASA researchers have been striving to meet the goal of sending astronaut crews to the Moon, Mars, and beyond. Although there are numerous technological and logistical hurdles to get over, one of the most daunting challenges facing us will be protecting astronauts from harmful radiation. Here on Earth and in low Earth orbit, radiation risks are somewhat mitigated due to the protection provided by our thick atmosphere and our magnetosphere. But outside the protection of Earth, the radiation in space could prove deadly if humans are not properly protected.
Even though radiation studies have been going on for years, new questions are being asked in preparation for extended stays in space. Some of the key questions NASA researchers must address include, how can we assure survival and health of humans traveling far from Earth? What technology must we create to enable explorers to go beyond where we've been? And what new opportunities can research bring to enrich the lives of everyone back here on Earth?
To help answer these questions, we'll travel to some of the facilities that are allowing us to better understand radiation and the dangers astronauts may face. Up first, correspondent Tonya St. Romain spoke with Mark Weiland of the Space Radiation Analysis Group at NASA Johnson Space Center. This group is working hard to monitor and protect our crews from this dangerous radiation. Here's Tonya to explain.
Living and working outside of Earth's atmosphere is a very dangerous proposition. Extreme temperatures, lack of oxygen, and hosts of other risks make space a very hostile environment for humans. But one of the least talked about and most dangerous risks associated with spaceflight is radiation exposure. When astronauts travel outside of Earth's atmosphere, they're routinely exposed to much higher levels of radiation than are typically encountered back here on Earth. For this reason, the Space Radiation Analysis Group, or SRAG, is working to develop tools that will monitor radiation events caused by the sun and other radiation-producing sources. These tools will be used to help us better understand how to keep our crews safe from radiation exposure when traveling outside the Earth's atmosphere. I spoke with Mark Weiland at NASA Johnson Space Center to find out more.
Our team here at SRAG is a great group of people who's charged with keeping the radiation as low as possible to the astronauts. And we do this with monitoring, with shielding analyses of new vehicles, and with real-time support and mission control.
How is radiation measured in space?
We have to use different kinds of monitoring techniques than you use on the ground. If you work in a hospital or a nuclear power plant, they have radiation instrumentation which measures very different types of radiation than we're concerned about in space. So the instruments we use are very different. We also have monitors on unmanned vehicles. The GOES spacecraft, which watches weather on Earth, also has radiation instruments on it that we use. And there's other instruments that are closer to the sun that we look at. We have to measure this radiation because it's very damaging biologically to the crew. We know this from research that shows space radiation can be more harmful to people than radiation here on Earth. And it's also a legal requirement. Astronauts are classified as radiation workers, and so we have to monitor their exposures. We also, by doing this, we know when they approach administrative limits and legal limits, and so that we can take action to prevent them from getting there.
Where does radiation in space come from?
Actually, it comes in 3 different places when we're in low Earth orbit, like on Space Shuttle or Space Station. We have radiation from our trapped radiation belts, the Van Allen belts. We have radiation that comes from outside our solar system called galactic cosmic radiation. We also have radiation that comes from the sun during big solar particle events. Now, the sun has an 11-year cycle that goes from very minimum amounts of activity to very maximum amounts of activity. And during the maximum amounts of activity, we have lots of solar particle events and solar flares, and we can get radiation from those events. Now, when we're going back to the moon and we're outside of the Earth's protected belts, it's going to be much more dangerous for the crews. We can cause acute effects. The crew can get sick very rapidly, unlike they can on Space Station or Space Shuttle.
After about a half-century of human spaceflight, radiation detection and predicting space weather events is still not an exact science. Unfortunately, we cannot accurately determine when large particle ejections, called coronal mass ejections or CMEs, will occur. A large CME can contain billions of tons of matter that can be accelerated to several million miles per hour. At these speeds, particles can reach Earth in a very short period of time. When the particles reach us, they collide with our magnetosphere and create auroras over the polar regions. Although beautiful to watch, the events which lead to this phenomenon can be very damaging and dangerous to astronauts outside the protection of the magnetosphere. In fact, between the Apollo 16 and Apollo 17 moon missions, a large solar particle event occurred. If astronauts had been in space during the event, the doses of radiation they would have been exposed to could have produced severe health effects within a short time. This is one of the main reasons better radiation prediction and monitoring are a focus of study.
How much time do you have to predict solar flares?
Well, it's actually very difficult to predict space weather. Just as we have a very hard time predicting hurricanes and tornadoes here on Earth, it's very difficult to predict when a solar flare is going to happen. A lot of solar physicists around the world are working on that problem, but right now we don't take action with the crew until we measure an increase in radiation. We are looking at trying to predict when there's an all-clear period. That'll allow us perhaps to do an EVA on the surface of the moon when we know there's a 90% chance we won't have a bad solar flare within the next 2 days. Yeah, the sun has an 11-year cycle, and every 11 years it goes from solar minimum, 5.5 years later to solar maximum, and then back to solar minimum again. During solar minimum, there are very few sunspots, if any, and thus no solar flares. All the solar flares and solar particle events come out of the sunspots. During solar maximum, we have a lot of activity going on with the sun, and we have a lot of solar particle events. So during solar maximum, we're very active in mission control, trying to keep the crew from getting too much radiation from those events.
Is there a difference in the sources of radiation in space?
There actually is. From solar particle events, we can protect the crew from that type of radiation. From the galactic cosmic radiation, it's very heavy ions, high energy types of particles that we cannot shield against. It would take too much shielding and is cost prohibitive to put that much mass up there. And the reason we try to keep the crew's dose as low as reasonably achievable is because any increase in dose is directly proportional to an increase in the probability that they'll get a fatal cancer. And unlike many of the risks that astronauts are exposed to, and there are many, radiation is one of the few risks that they will carry with them the rest of their life.
Do you think our predictive models will change dramatically for future missions?
Okay, actually, I think they will get better. I believe that all the science that's being done by all the solar physicists and the space physicists is going to lead to better predictive models. They're doing a lot of great work. They are launching a lot of new missions, and those missions are there to explicitly study the types of physics that will lead to these better models. As we prepare to go back to the moon and Mars, our team here at SRAG is extremely excited to be a part of that effort of keeping astronauts safe. For me and my team to be standing over in mission control when we step foot on the moon again would be one of the greatest achievements of my lifetime.
Space radiation is not typically harmful to us on Earth because the Earth's magnetic field extends thousands of miles out into space, helping shield us from the dangerous particles. Up next, we find out how radiation may affect astronauts on longer duration missions. But first, did you know that some astronauts from the Apollo mission through today have reported actually seeing radiation as flashes in their eyes? The flash the astronauts experience is space radiation zipping through their eyes like subatomic bullets. When the radiation strikes the retina, it triggers a false signal that the brain interprets as a flash of light. This is problematic because this radiation kills brain cells and also can trigger long-term problems such as cataracts, which is a clouding of the lens that focuses light on the retina. Research is now underway to help develop probes that can detect signs of cataracts in humans years before they become visible. Eventually, astronauts might carry such a probe with them on space missions, checking their eyes as they go.
For many years, NASA has been sending robotic spacecraft to faraway planets like Mars. Some of these missions have included instruments that have given us a basic understanding of the types of radiation we can expect outside the Earth orbit. Even with this knowledge, there is still much to be learned about how the radiation in deep space will affect our astronaut crews. To help increase our knowledge base, a unique facility called the NASA Space Radiation Laboratory is testing living cells with the types of radiation found in space. Our Johnny Alonso traveled to the Brookhaven National Laboratory in Long Island, New York to find out more.
Radiation exposure is a very real risk for astronauts. Ailments such as cataracts and many forms of cancer can be directly attributed to high exposure levels. Because most of our recent astronauts have remained in low Earth orbit where the Earth's magnetosphere provides some protection from radiation, exposure has been somewhat limited. But with future astronauts traveling to destinations like the Moon and Mars, radiation exposure will once again be at the forefront of study. To help us prepare for these dangerous space missions, NASA, in cooperation with the Brookhaven National Laboratory, is conducting research to help us understand the biological effects of space radiation. I spoke with Dr. Marcelo Vasquez at the NASA Space Radiation Laboratory here in Long Island, New York, to find out more.
Well, basically, I'm interested to find out if a galactic cosmic ray can kill brain cells. So in order to understand that, we have different models. For example, culture cells and petri dishes, expose them to cosmic rays and see if the cosmic ray can kill brain cells or produce some functional damage. That's one part of my research. The other part is study animals. If after cosmic ray radiation, they have some kind of behavioral changes or functional changes after long terms after their exposure. Basically, we want to try to understand the risk for astronauts for neurological damage induced by cosmic rays.
So how is galactic cosmic radiation different from other types of radiation?
Basically, we can say that the origin of these galactic cosmic rays are far, far away from us, outside our galaxy. Basically, supernovas well beyond our galaxy explode and produce this kind of tremendous release of energy, and that energy is cosmic rays. So cosmic rays are basically atoms, elements, that travel in space near the speed of light. And one of the big unknowns is what kind of biological effect this cosmic ray can produce on astronauts. And this is really important for the new exploration mission to go back to the Moon and go to Mars. So our concern is that those cosmic rays, those atoms that are flying through the universe, they have the potential to produce damage. So one of the goals is try to find out what is the best strategies to reduce the risk for astronauts, for example, for Mars mission and Moon outposts and sorties. There's several ways we can protect, and we believe that this radiation risk is not a showstopper for astronauts, but there's a lot of unknowns, and that we need to reduce those unknowns in order to send astronauts in a safe way. But no matter what, astronauts with the best shielding, the best strategy, always will be exposed to some level of radiation.
How do you simulate galactic cosmic radiation on Earth?
We have what is called the NASA Space Radiation Laboratory. It's a facility to simulate the space radiation environment for biology or material sciences. So we have at Brookhaven big machines called particle accelerators. We benefit for that because they can accelerate cosmic rays like iron or carbon to the speed and energy that you will encounter in space. So these big machines deliver in a controlled fashion those heavy ions or charged particles to a target room. And so we can put cells, tissues on molecules in our target area and expose to those cosmic rays to understand what are the basic mechanisms. So the NASA have a research program addressing different topics like brain damage, cancer, DNA damage repair. It's a multi-user facility dedicated to support the NASA Radiation Health Program.
How will biological research assist us in keeping our astronaut crews safe?
The first step is to understand the mechanism. So imagine this. These heavy particles traveling out through your body traverse your cells, your skin, your brain, or liver. And we know for the fact, by our basic research, that when these particles traverse a cell, produce DNA molecule damage.
Ionizing radiation is a stream of particles that, when passing through a body, has enough energy to cause the atoms to lose electrons. These heavy ions can damage living cells and may cause changes in the cell's ability to carry out repair and reproduction. This could lead to mutations in an astronaut's cells, which may result in tumors, cancer, genetic defects in offspring, or even death. By one NASA estimate, for each year an astronaut spends in deep space, about 1/3 of their cell nuclei will be hit directly with heavy ions. With this knowledge in hand, a big push is on to better understand exactly how to properly protect our new exploration crews. Can you tell me the risks of long-term exposure versus short-term exposure?
Overall, NASA is concerned what is the total risk imposed by solar particle events that will be acute, so a really high dose of radiation delivered in a short period of time. But the good news is that we know how to protect astronauts for that. But one of the big risks is the chronic low-dose exposure to galactic cosmic rays, and we still are thinking what is the best way to protect astronauts for that kind of risk.
In one study, it was determined that an astronaut on a 900-day Mars mission, housed inside a conventional spacecraft, would encounter nearly 1.1 sieverts of radiation. That is the equivalent to the amount of radiation one would be exposed to in 550 years on Earth.
So what does the future hold for this type of research?
Well, I think it's a bright future because for NASA and the plans to return to the moon and go to Mars, radiation is a really critical risk to need to be studied. So our research will play a critical role for future plans.
In the hope to better train and disseminate information about effects of these particles on living cells, researchers at Brookhaven National Labs also host a summer camp that teaches rudimentary particle physics to future and current biologists. Coming up, we'll find out how NASA is developing new shielding and protection procedures. But first, did you know that the Concorde jet had radiation detection equipment on board to protect the crews and passengers from galactic radiation? This type of equipment was needed because of the high altitudes the jet flew. Typical commercial aircraft generally fly between 20,000 and 40,000